Hello and welcome. Today we're going to do some testing with Stable Diffusion on an NVIDIA RTX 3060 using the ComfyUI interface. Yes, UI interface is redundant. It's a user interface. Let's get started. I'm going to show you everything in real time just to provide some data about how these cards work with this technology. I've already got a workflow loaded up here. We're using a Stable Diffusion 1.5 model, and we're just going to generate the base 512 by 512 image size. I'm going to put the prompt and the resolution that we're currently working at up on the screen. But if you want to like fast forward around the video and see different resolutions that we create. So why don't we queue up about 5 of these and just let them run. Okay. I'm going to change things up a little bit. Let's make a batch of, say, 6. When you create multiple images, it does provide a boost to the speed. There's some bottleneck that one image has to overcome, that it has time to draw other 6 images a little bit faster. It took about 15 seconds to draw 6 images. Not bad. All right. Let's go back down to 1 at a time, and let's do a little bit bigger. Why don't we do 640 by, let's just start with 800. Why don't we do about 4 of these back to back? We're doing those in about 6.5 seconds. Let's go up to 960 for this, and these will be the last that I do at a single pass. And I'm going to swing back around and do some Stable Diffusion XL, but I'm going to wait until I have exhausted all of my tests that I was going to do on 5.1. In truth, if you're doing the same image size, the model does not matter. The only thing that an XL model provides you is much better image cohesion at larger resolutions. All right, there's our 640 by 960 image. Now let's add a step to this. We're actually going to come over here to this upscale by latent group I've got. We're going to turn it on. And I want to upscale this by 1.5. And I'm going to use the base settings that you get when you load these nodes in. Okay, so we got us a 960 by 1440 image here. Now, let's do something different. Let's make a smaller image, 320 by 480. And then let's upscale it by 2. So what we're doing is, at first we drew a 640 by 960 image here. Now we're going to draw a 320 by 480 image and upscale it by 2 to 640 by 960. So basically we're taking 2 steps to make the same image. So it is going to take a little longer. However, this early image is incredibly fast. So you can do some stuff with that. For instance, if you don't like the image, you could cancel the generation over here. Now that does require you to kind of manually sit here and control things. If you want to step away while images generate, it's not a good technique. Another thing I'm noticing, and this is one of the reasons why I'm going to try this technique here, is that when you generate a 640 by 960 image initially, you can get aberrations like feet facing the wrong way, extra arms, what they call totem pole heads, where they have multiple faces that are stacked on top of each other. This right here, it's 960 by 1440 image in 30 seconds. Now we're going to do this trick where we generate a very small image and then we upscale it to the medium-sized image. See, if I didn't like it here, I could hit cancel. And actually, I'll show you that right here. Let's say I don't want to generate this one. I would just hit cancel right here. Then it will redraw that one. Give me a new image. This takes about 10 seconds to upscale this guy. It does take longer than just starting from this image, and you may even argue that just starting from this size is fine. You'd probably be right in most cases. I think this does cut down on strange aberrations. It has a very easy to draw image here that it can do good on. And then it can upscale it using that as a reference, and it won't run into any of the problems. However, your mileage may vary. If you want to try this, I'd encourage you to test it out and try different things. Now that we've done this, let's take it one more step. Why don't we upscale it with our ultimate SD upscaler? Let's turn that on. And right now, my image here is coming from this guy over here, this small image, right? So this is 2 separate methods to upscale. This is upscale by latent, and this is upscale by ultimate SD upscale node, which is a form of, it's a control net. I think it's a tile control net. So there's like, you can set the tile height that it draws the images by. What it's doing is it takes this image, well, actually it's taking this image, it upscales it by 2, and then it divides it into these tiles that are, you can define the size of them. And it will simply draw it, and then it'll draw the next one, it'll draw this one, draw this one. So this happened in about 38 seconds, it looks like. I wasn't paying attention when it happened, but I can see the command line. I'll try to point it out when it occurs here. Speaking of, this is a 960 by 1440 image. So when we were starting here and upscaling it by 2, which they would be here and here, it wasn't taking as long, but you might argue There are advantages to doing it this way. It's interesting, it did it this one first and then this one. There is a strange order system to this, and it has to do with these end nodes. Like right here, this image save, this is an end point. So when it builds the prompt or when it builds the workflow, it starts at these endpoints and goes backwards to the beginning. So for whatever reason, the order, this preview image is also an endpoint, as is this one, as is this image save. It does these first. There are ways you can control that, but it's not that big of a deal. So you'll notice this image and this image are very similar. And then this image is different, but it has the same, like, you know, the colors of the dress, how it goes from blue to white. There are similarities. One thing I've noticed, I had this on 3. I didn't realize that. So we were actually getting, this is a bigger image right here. We're actually like skipping step. We're going from 320 to 640 to 1280. Or wait, this isn't 1280, is it? No, it's 960 by 1440. So we could have upscaled this one by 1.5 and gotten to here. It would look more like this image. Actually, let's do that. Let's take this down to 1 and connect this. So now this image is being fed into our ultimate SD upscale node. So instead of this image looking like this image, it's going to look more like this image. And I think in this workflow, this will now perform first because this guy was relying on input from him. And we're almost done. There you go. That took 43 seconds. Here's our starting point. Here's our first upscale. Here's our second upscale. Well, I guess now the only other thing to do would be to test out Stable Diffusion XL, although I think the results are gonna be very similar. In fact, even though XL is not great at doing 512 by 512, we'll try that just to get a baseline of what we're looking at, and it should be nearly identical. There's our 512 by 512. This is Juggernaut XL version 9. All right. Let's do the same thing we did earlier. Well, let's do what let's show off what SDXL is good at, which is 1024 by 1024. I think we'll be getting one of these every about 15 seconds. We'll see. 17.5 seconds. Do one more. All right, why don't we, just for fun, to close out this video, we will enable upscale by latent. We're going to make this a 2048 by 2048 image. We'll see how long it takes. This is definitely the biggest thing we've created today. Getting at 2048 by 2048, we're getting 3.8 seconds per iteration. Since we're drawing 20 times, you can say, you know, 4 times 20, about 80 seconds, I guess. A little bit less than 80 seconds. But that's how you might calculate that. And this will be the last thing we do. There we go. 2048 by 2048 image. That took me 100 seconds on my 3060. All right. She had 3 feet too. Thank you for watching. And I'll see you next time. Have a great day.